Alright, there we go. Good morning, everyone. Everything should be set up correctly. Well, hopefully the music's not too loud. I realized that copyright doesn't really matter. Good morning, Robert Brown. Let's see. And there we go. So, unlike last time, I am actually a little bit prepared. Now, I did set up what I want to go through. Make it tinier. Make it tinier. And good morning, Nander. Welcome. Hopefully that's fine. It might be too quiet. And good morning, Egos. Can you get a hall pass? Fine out. I need a student to take the papers to the principal's office. Yeah, you can go, I guess. Okay, I'm gonna call the... You're not gonna smoke in the bathroom? Okay, if I call the principal and he doesn't get those papers, you're fucking dead meat, kiddo. Oh yeah, kids don't even smoke anymore, they just vape. God damn it. The education system is in shambles. Kids don't even know how to light it. No. Don't smoke. Don't vape. Don't be a little shit. There's the real takeaway. And good morning, Akira Dulce. Welcome to class. Yeah, I'm a little bit late. Maybe I should make everyone else take a... Write their name on the little billboard that says you're late to class. But yeah, we're gonna be going over some more Algebra 1. This time I won't wander off into derivatives. Because I was looking for an equation to solve. But the main thing is after we go over everything, which shouldn't be too much, we can actually apply some of the math to video games. Because why else? I guess once we start getting into other stuff, we could just do like cool card game analysis, or like do a little bit of hypergeometric calculations, you know? Find how many goblins you can draw with your goblin lackey. I mean, ringleader. Anyways. That kind of stuff is interesting. But I would also like to name a layer just cheat sheet. Don't mind the typo there for a second. So, one of the main things with algebra is, I guess, reducing and simplifying equations and just getting everything down to the simplest possible form. Let's start out with the most basic, I guess, formulas that you should know. Work your way through an university-level algebra textbook. Maybe. The site... Oops, hopefully that wasn't loud. The site that I've been using as, like, a syllabus, pretty much. It does have some example equations. Those could be fun. But I do already have a graphing website open so that we can do some cool stuff. And by that, I mean compare DPS. It's the only thing I can think of. But anyways. So, here's some easy ones. Very easy ones. Let me make the brush a bit smaller. So you should be able to figure these out. And memorize these. There we go. I just want to get the handwriting right. There we go. A minus A equals 0. That's not too impressive. So like 3 minus 3, 1 minus 1, -1 minus -1. Yeah, the usual. And so A is just any integer, I guess. Or really anything. A divided by A equals 1. Alright, and are there any others that we need to do at the moment? I guess... Maybe the... Well, yeah. The nth root of a to the power of n equals a. I think those are all the ones that we can do right now. There may be some silly stuff that I'm just like skipping over, but that's useful to know. So if you've got 2 squared and you're trying to find and you have to take the square root of that, it's 2. There you go. Alright, well. We'll come back to that and put some more, I guess, formulas on there. Like maybe even the quadratic formula once we get there. But let's start with the very basic idea of algebra. I did do this before, but this is very, very simple. Okay. I don't know. Yeah, you got 2 boxes, you don't know how much they weigh. Well, you got 1 box that you know weighs 2 pounds. You've got 1 box that you don't know how much it weighs. And you know that both of them together on the scale, or whatever, is 5 pounds. Well, if you're... if you pass 3rd grade, or if you managed to get here, answers 3 pog. Good morning, mozzarella fella. You would be correct. You can just solve it if you do this. Correct. There you go. Little do you know, you've just solved an algebraic equation. Because when all those funny equations have x in them, it's just a variable. It means it can be anything. And usually, for mathematics, when you're solving shit like this, it's usually an unknown. So, yeah. That's it. And now, let me tell you something that you probably know already. When you do something like, I don't know, 3 plus 5 equals whatever, and it gives you that question in a textbook. Guess what? Guess what? 3 plus 5 equals x. Solve for x. There you go. Now you've just you've been doing algebra the whole time and you didn't even know it. The answer is 8, by the way. But so yeah, the main gimmick with algebra is the equal sign. We know both sides of the equation are equal, so we can use operations on both sides. As long as we do the same thing to both sides, it should be equal. Well, not should be, it will be the same. So, the same way that we can do, 1 equals 1. Let's add 2 to both sides. 3 equals 3. Wow, would you look at that? We just proved we can add to both sides. There we go. So, here's how we do this. If we want to solve this equation, I guess the way that the teachers want you to, showing all work. You can't just say 3 because that's too easy. You would have to work through this. So, what you want to do is put x on one side of the equation. So, you just get x and a number. So, the way you do that, we've got 2 over here, just subtract 2. Well, take a look at that cheat sheet. Well, what do you know it? That equals 0. That's why I wanted to put that on there. It's just because a number minus itself equals 0. Which is stupid to have to write out, but I wanted to. So, anyways. That'll help you think about the later stuff a little bit. Probably not. But anyways. So. 2 plus x minus 2 equals 5 minus 2. Cool. 2 minus 2. X plus 0 equals 5 minus 3. Minus 2. Okay. Oh no, I'm already failing. Alright. So, you can do that math. In fact, I'm certain you did it in your head earlier, but yeah, that's the basics. Now, let's do, I don't know, 3x equals 15. This is a simple one. Now, that's why I brought this up earlier. You see, we're going to do the exact same thing, except with dividing. So, and let me put a line between these. There you go. Just so the space is a little bit more readable. Oh yeah, I forgot. Last time, I was really needing this, and I didn't have it enabled. Is it in view? There should be. No. Show grid. There we go. Oh no. Where's the grid options? That's fine. There should be a way to put it behind the text. I don't know, it's Krita. Who knows? Hopefully that's... Oh, that looks a little weird on OBS. It looks a little spicy. Hopefully that's fine. However, guess what? We can divide both sides of this equation by 3. So, 3x divided by 3 equals 15 divided by 3. And 3 divided by 3, that's 1. And that's why I brought it up. Eh? See? I did do a little bit of preparation. And then 15 divided by 3 equals 5. And there we go, we've solved it. Now that we know that x equals 5. Oh yeah, here's a very important thing. If you're doing this on a test, you want to check your work. Because, well, unless you're timed on the test, or, I don't know, you just don't care. But, you can always check your work. Because at any point in this equation, we should be able to substitute 5 for x and get the correct answer. Like, the equation should still balance out. So that we can just dump that in at the start. Now, these are very boring equations so far. But 3 times 5 equals 15? If you put this in your calculator or you just do it in your head. 5 plus 5 plus 5. You get 15 equals 15. Holy frick, Lewis. Same thing over here. 2 plus 3 is that's 5. Yeah. So, there you go. And then one last bit for the super simple algebra is, let's see, everyone knows the Pythagorean Theorem. In fact, wait. Oh, I can even do this correct, like with the correct units. 3 by 4. Whatever. If you have a right triangle, like this, You label the links like this. And this will be useful. But let's see. Yeah, triangles are interesting. There's the whole subject of trigonometry, which has a lot to do with triangles. I guess that's for a future segment, but here's the Pythagorean Theorem. A squared plus, b squared equals c squared. So, yeah, this is why algebra is fun, because if you note two of these, like so, let's see. I don't know. We do 3 and 4 for the length a and b. Then we can get a nice little equation. 3 squared plus 4 squared equals c squared. So now we want to solve for c. So yeah, let's say we wanted to find that length. The most practical use of this is, say, I don't know, you got the football field or something. No, welcome to video games. See, this is the reason why a lot of tabletop systems will use grids. Because first of all, squares are easy to draw. You just take a ruler, just go, and then you turn it the other way around. Any sort of straight edge. But the second reason is... Oh, the reason why it's tabletop and movement is very silly. Because a lot of systems either go... You move square by square, like so. Bam. Bam. Only cardinal directions, no diagonals. And some do allow diagonals. But it usually only counts as one space. There's a lot that goes into it. Different games definitely treat it different ways. But yeah, say you're playing D&D or whatever, and you're using squares for the grid, and you want to know how far away you are from the enemy goblin. There you go, that's a bad guy. So say each of these is a square. Like this. I do have the line tool. Whatever. Yada yada yada. Okay, I'm saying that, but I'm just doing it all by hand anyways. So, 1, 2, 3. You know, he's 3 squares down and 1, 2, 3, 4 squares over. And you want to find the direct distance. So, the way that you do that is by calculating the hypotenuse. I think, yeah, the C in the old Pythagorean Theorem. I said I'd apply it to video games after, but fuck that. I'm doing it now. So, let's go ahead and solve for that. So, A is 3, and B is 4. So, let's go ahead and square those. 3 to the power of 2 is 3 times 3, which is 9. Plus 4 to the power of 2 is 4 times 4, which is 16. And plus C2. C to the power of 2. Now we can simplify this further. And we get 25 equals C to the power of 2. Now, the problem is, this is not a good enough answer for us. If you were lazy and you just gave up here, you'd say the goblin is 25 units away from you, which is entirely incorrect. And you would get the 0 points on the test. However, if we go ahead and... Oh, thank you for the raid, Everweather. Welcome to math. Where's my mouse? There it is. Let me go ahead and... also, you're all late. You're all late for class. I'm sorry. I suppose Kids these days. But yeah, good morning, Attenborough. Fuck. Don't worry, the state won't actually let me punish you or anything. But there we go. But yeah, good morning. How was your stream? Oh yeah, I did. I did put the doodle redeem back on. So far unused. Yeah, good morning, everybody. Welcome. But yeah, here we go. Yeah, and good morning, Gail. Normally slept in math class. Cringe. Thank you for the gift sub. Based. Okay, now give me your phone. No. No. So, doodle redeem. Oh no, I don't remember the exact conditions I set. Yeah, the closest thing I'll do to a commission. But, yeah, the nth root of whatever to the power of n is that Terazaku. I didn't say it would be good. I'll leave the cheat sheet clean, and I'll come back to that in a moment. But, taking the square root of a squared equal... Actually, yeah, let me go ahead and draw on this. So... Rio. Oh, fuck. You bastard. So... nth root, yeah, we can just do, like... the regular old square root does not have the number. So... Yeah. Draw a Gundam. Good morning, Pig VT. Channel. Education? Too late, buddy. Let's see. What does Zaku look like? Something like that. Got like the... Something like that. And then what, like a gun? Like an axe? The screen's blank. This happened before. There we go. That happened like months ago. Well, thank you for telling me. Just pressing Control S. Gundam. Fuck, I don't know what a Gundam looks like. I think. Got like the funny like laser axe. I've only seen War in the Pocket. Hold on. Okay. There you go. Bernie pilots a Zaku. Okay, yeah, I know that. But and the enemy is a Gundam, yeah. That's why I give him the axe. Does Char pilot a Zaku? There was a Gundam. Okay, yeah, okay. There we go. Eat your homework. Maybe like half the time? Huh. Not you bastard, you asked for it. What is this? What does the OC look like? I forgot. We're destroying mathematics just for the sake of this. There you go. Bastard. There you go, there's the teardrop. Killed a man in prison. I can't believe it. and then a Gundam. Let's see. What does a Gundam look like? It's got, yeah, the weird eye horns. The eyebrow horns. What does the mouth look like? Math. Good morning, Blessed Heretic. Welcome to Quick Math. Like the weird sideburn grills. Okay. The Doodle Redeem has been found out. Yeah. Just a little bit of goofing around. There we go. Okay. Well. A little bit back on track. Play Nier Replicant. Yeah, no, the Nier soundtrack is like 10 on 10. I do prefer the Nier Gestalt and Replicant like original soundtrack as compared to the re-release and the Automata soundtrack. It's just I feel like the remixes lose a little bit, but yes. So we take the second root, the square root of a number to the power of 2, or the number c squared in this case, and we'll just end up with c. So what we're gonna do is square both sides. So take the square root of 25 and the square root of c to the power of 2. So we know that will cancel out to just c. And the square root of 25, well, 5 times 5 is 25. And there you go. Congratulations. Nice. Attenborough got it wrong with 88,888,000. No. Thank you for the potches. I couldn't resist making that joke. So. Oops. Okay, I never figured out what the. I never figured out what the Everweather was doing. Whatever. Too late. So, oops. This is 5 units long, and then our example. The goblin is 3 units down, 4 units that way. Oh, papers, please. That's a fun game. But we can figure out that distance is exactly 5 units away. There we go. So we've gone through the basic algebra stuff. It gets fun once you combine it. What is this? Oh, that was that. Let me delete that. No one needs to have a good morning anymore. But yeah. Now we get to have fun. Good. It hasn't deleted itself yet for some reason. That's weird how it's blanking out every once in a while. But anyways, I can't think of any great video game example for this, but if we take a more complicated equation like, I don't know, x times 3 plus x. Plus 5 times, I don't know, x minus 1 equals, I don't know, 25 is a good number. So, we need to simplify this. Because obviously, if we start messing around by adding and subtracting to either side, we'll just end up making the situation even worse. So, here's where the fun begins. So, just like you could multiply a number into numbers in parentheses. So yeah, we can't reduce this term or whatever, because we don't know what x is, so we're just stuck with 3 plus x. So, we'll have to multiply it out. We're gonna get into linear and parabolic equations. Soon, actually. This stream. You lucked out. Yeah. Will this be on the test? There's no test today. I didn't have time to prepare one. Instead of preparing for the stream, I just prepared for other streams by playing Gungeon. How far is natural log and e? I mean, I already went over them before, and they kind of suck. The main purpose of e and natural log and all that stuff is like statistics and derivatives, I guess. Yeah, I don't know. Not for now. Don't worry. I think that might have been the first math stream that I brought that up. Anyways, so we can just simply what is e to the ix? Isn't that 1 or something? No, e to the I pi is like 1, yeah? Something stupid like that. So, just like division, or multiplication, like normally. In fact, let me use the square example again. So, we can just do x. We've got like a rectangle, not a square. we know it's we know one length is x, and one length is 3 plus x. We can separate it like so. So we know the area, if we want to find the area of this, aka multiply these two numbers together, or two terms or whatever. Whatever. We can just get 3x plus x squared. You know? So you know this is this length is x, this length is x, this length is x, this length is 3. It's just long multiplication, but with funny numbers that we can't solve for yet. So, what that looks like in practice is you just multiply the first number by that, and then the second number, whatever. Yes. 3x. Good morning, Karagi. Nice graph paper. Nice face, nerd. Get dunked on. And we can do the same with a regular number. And like so. But yes. So, we'll go ahead and add... Whoops. 5x. And negative 5 times 1. Or just subtract 1 times 5. Holy shit, it's 5. Yeah, welcome to math class. Damn it. Hold on. Can't do this with paper. Right? Don't tell anyone I messed up a little bit. Math sucks. Okay, that's going too far. No. We didn't really need to put this in parentheses, but if there's a negative, English class is cooler. Okay, listen, Buster. No. Ooh, we could use this equation for some other stuff in the future. And by in the future, I mean right now. So, let's go ahead and simplify this further. So you want to order it in... you want to make it look like this, with the higher exponents first, just because it's cooler. No, that's just the standard way of doing it. So, x squared plus 3x plus 5x minus 5. This thing? Always forget how to do this? Wait, which part? Yeah, if anyone has any questions, that's what I'm here for. But yes. If you think about this way, 3 times x plus 5 times x, you can just add the 3 and the 5 together. Factoring. Yeah, we're gonna have to do that. So, we get x squared plus 8x minus 5. Is the parabola thing you forgot? Maybe. Yeah. Yeah, welcome to parabolic equation. There would be. Yeah, this is just a quadratic. Yeah, if I said y equals... If I... Check this shit out. Y equals this, or... If I just make it a function. I don't know, f of x. That means practically the same thing. And a function is just anything with an input and an output. So... good morning, real brain man. Yeah, teach you how to find the function matrix's derivative of matrix. Frick. I wish it was funky. But however, we're not getting into derivatives yet. So we've simplified the equation as much as we can. But... yeah, the proper form for one of these bad boys is... Yeah, a quadratic equation is... Whatever. What did I do? Oh no. Yeah, welcome to math. A x squared plus b x plus c equals 0. There we go. So, if we want to use the quadratic formula on this, we'll have to do something unexpected, which is subtract 25 from both sides. Well, I guess no, you don't really need to. Doesn't matter too much. Well, whatever. Makes it nicer. So, well, I mean, we could do it like this, yeah? Wait, does this actually work out perfectly? No, we can only get... No. X squared plus 8x equals 30? Oh yeah, that's another way we could... Well, no, then we'd end up with some other nonsense. Well, let's do it this way. Because the thing is, it's math, baby. It doesn't matter as long as everything... as long as you do every step correctly, it's still equivalent. Let's see if we can find a proper factor for this. So, oh shit. I should show the opposite way. The opposite end of this. So, we go like x plus 3 times x plus 5. You can multiply two binomials, which is the two-term numbers like this. So what that means is, yeah, this is where FOIL comes into play. So we've already done this before. We've multiplied one number into parentheses like so, but we can do that with two numbers like so. Multiply term thing by term thing. Yeah, this is FOIL. First, inside, outside, last. However, you can just do it however the hell you want, as long as you get it right. But what they teach you in school is you want to multiply the first numbers, the F in FOIL, the inside numbers, the outside numbers, and the last numbers. So what that ends up being is, first, x times x, you'll get x squared, and then inside 3 times x. FOIL. Ah, fuck. Listen. It doesn't matter. English class sucks. I get more than how to fix. That should be correct. But yeah, 3x for the... Fine. First, outside 5 times x. Yeah, that should be correct. Inside 3 times x. And last, 3 times 5 is 15. This is how math ties into trading card games? No, we will have to go into hypergeometric calculations later then. Not today, but someday. Because yeah, you have to know how likely you are to draw how many goblins every time you cast a goblin ringleader, okay? But anyways, yeah. So, yeah, that was a correct, yeah. Extra non-Euclidean spatial dimensions. Hypergeometric does not actually have that kind of weird nonsense going on with it. I don't remember why it's called that. But there you go. That's how you do something like that. Now, the thing is, you can do this backwards. So, say, you didn't do all this work, and now you have this. So, now you gotta solve for... you have to turn this into binomials like that. Well. Let's see. Can we do that with this? So the thing is, we have a negative number. So, let's do this a slightly different way. What about x minus 3 times x plus 5? 65,536 goblins are attacking right now. What do you do? Hope my opponent concedes. I win the game because I'm the one with that many goblins. No. So, this is a little bit similar. We do the foiling and all that. First, x squared. Outside. Goblin Slayer, no. I cast Tividar's Crusade using Flash to give it instant speed. Whatever. Plus, inside... It's a negative. So... We're gonna have to subtract. Well, we're gonna add negative 3x. And then add... Ah, shit, that's a negative. Negative. 15. So we end up with x squared. So 5 minus 3 is 2 plus 2x minus 15. So yeah, the only way to get a negative number at the end of the equation is have the, I guess, one of the numbers be negative in this. So we've got that over here. 2 for 2. No. Fair enough. So, is there any way? I mean, 6 times 5, yeah, is 30. However, we can't reach 8 with that. What about, what, 10 times 3? Damn it, no. Let's see. So, this is, A minus B, and this is A times B. Is there any number where this will actually work? I think it would end up being a little silly for this. Now, good morning, Art Sounds. You didn't know math was a category? You're late. You're late for class. Yeah, good morning, welcome. Please sign your name on the flipboard. Be easier to use the quadratic formula? Yeah, I'm trying to see if I can. But, yeah. Well, welcome to the quadratic formula. And good morning, Quexty. Woody. Quexty? Yeah. Yeah, welcome to math. The new soundtrack is indeed based. Yeah, I'm probably gonna get the VOD muted a little bit. Last time you did this was in middle school and you're a social science major. You skipped math in high school. Fuck. God damn it. I see. But yes. I don't have it written down. Okay. I can't mess this up. This is for all the marbles. Quadratic formula. I am shouting audio jungle constantly in my mind. Here we go. So, this is why you want a trinomial? Whatever. Yeah. The near audio jungle soundtrack. No! So, this is why you want it in squared x nothing. No. Because this is how you do the quadratic formula. So x equals wait. Whatever. That's not exactly how it's... I'm not gonna fuck around too much. Don't dox your private voice chats. What the hell are you doing? Negative b. Now, okay, this is gonna fuck with you. Plus or minus the square root. Oops. Of b squared minus 4ac over 2a. Okay, good. Yeah, there wasn't enough room to fit the whole thing. It tells you how to find b. Hey, how do you find d? These nuts get dunked on. What do you mean? No, I already got you. But anyways, let's go ahead and do that. So we do have the formula in the correct way. Ax squared plus bx minus c, except we've got actual numbers instead of stupid variables. So we can replace these stupid variables with actual numbers. Okay, have a good night. Sleep tight. Don't let the math bugs bite. So, well, I need to read that again. So, negative b. So yeah, a would be 1 in this case. A number multiplied by 1 doesn't do anything. Whatever, don't worry about that. Well, whenever you've got like a variable by itself, you can imagine it's 1 times that. So, whatever. So, do the quadratic formula. Negative 8 plus or minus the square root of 8 squared minus 4ac. Uh-oh. This might be not real. A is 1 in this case. 4 times, let's see, negative 30. No, this should be real. Yeah. We should be good. We should be fine. Yeah, because we're adding it. Yeah. And over 2a. A is 1 in this case, so over 2. So this is why you need PEMDAS and all that. So, parentheses, exponents. We go way deep in there. BODMAS. Oh, that's for like stupid fake countries. Doodle visual interpretation of 1 divided by 0. It's not that impressive. I did mess around as a young man, as a young bag in school, bored out of my fucking skull with the system where you have a variable for 1 divided by 0. I never got anywhere because it's stupid and it doesn't actually get you anywhere. But I just used this symbol. I don't know if it actually. I just thought like, oh, enough scribbles. It looks a bit like a Z, like a 0, but you can just do it in 1 stroke. There you go. Secret bag lore. Anyways. Tell no one. So let's go ahead and finish this equation. So 4 times 1 times negative 30. Well, 4 times 1 is just 4. We don't need to bother with that. So 4 times negative 30 is negative 120. Yeah. So, oh man, there's not enough room for this really. We got plenty of room over here. So 8 squared minus negative 120. Oh boy, howdy, would you look at that? Minus a negative equals a positive. So we're just adding 120. Oops. There we go. Now 8 squared is 64. So 64 plus 120 equals 184. So we get -8 plus or minus the square root of 184. I didn't need to make it that big. All of that divided by 2. So we can already take the -8. We can just do, see, the plus or minus is the interesting part, because we'll have 2 answers. And guess what? We're gonna have 2 numbers to fill in. The A and the B. Or whatever, for the quadratic nonsense. Anyways. I never really bothered remembering too many of the names of the terms. Because, I don't know. But, let's go ahead and do the square root of 184 over here. It's 2 points where it intersects on a graph. Yeah. Yeah, if we graph that out as... If we replace that with a y. Yeah, if we made it a function, then yeah. In fact, we are finding the 2 points where it equals 0, which is the answer to this equation. Yeah, that's why we had to get in this form. There we go. Yeah. So, the real answer is you just plug this into your calculator. Because it's not a perfect square. The square root of 184. Ah, that's a silly number. So yeah, if you use this on a function like this, then yeah, you'd find the points when it equals 0 on the graph. I mean, we will be graphing something like that. But anyways, square root of 184 equals 13 point... I guess I'll round up to 2 digits. 2 decimal places. 0.56. So... There we go. -8 plus or minus. At least it's a rational number. Yeah, it'd suck if it was negative. Yeah, I did glance over that on the whole square root nonsense. Oops. The mathematicians are lying. All numbers are irrational. Speaking of, let's go ahead and simplify this a little bit. We just do -4. Yeah, the -8 divided by 2. Frickin' sweet. Plus or minus 13.56. Over 2. And let's just divide that by 2. I mean, it wouldn't be difficult to do it by hand, but there we go. So, -4 plus or minus. Wait, what? No, not all numbers are irrational. That's perfectly rational. But yes, in case you're wondering, the definition for an irrational number is a number that cannot be described as a fraction, aka cannot be described as a ratio. So, 1/3. And if you put it into decimal form, you get some stupid number like 0.33 repeating. However, it's not irrational. Some numbers are only irrational in base 10. I think you're thinking of something else. 4 plus or minus root 46. Good morning, Rando Lurker. Root 46. Oh, yeah, we could take 4. We could divide that. Yeah. Yeah? Wait. Yeah. Pi is rational in base 60 or something. I don't know if that's how that works. Is it? Yeah, you need an irrational base. That's it's not irrational, no. 1/3 is rational. The reason how would changing the numbers change that? It's not whether or not it repeats infinitely. Because if you take like base 12 or whatever, 1/3 would not. But with a number like pi or something like square root of 2. What is the square root of 2? Let's go ahead and put that in. That should be irrational. 0.414 bunch. Dictionary definition? Buddy, this ain't English class. Based? Oh, then all numbers are rational. They're all based. Yeah. However. 6.78. Why am I speaking English, not math? I am speaking math. Are there irrational imaginary numbers? Isn't that I? No, I is not. I mean, if you just go square root of -2, there you go. Irrational imaginary number. It's easy. I believe that's how that would work. You know, I'm not too certain. I think that would count, but I don't know. Well, I mean, it's certainly rationalist. So you could square root of -1 times square root of 2. But I don't know if that would count as... I mean, yeah. Yeah. No, you can't write the number. Now you've made it rational. You stopped it. You made it rational. I can express that as a fraction right now. Yeah, imaginary numbers need I, which is the notation for the square root of -1. So I didn't touch on this earlier, but you can't take the square root of a negative number because what number can you multiply by itself to get a negative number? So you can take the square root of 4. 2 times 2 equals 4. So you know that's 2. Square root of -4. Well, actually, I didn't touch on this either. Guess what? -4 also works. -2, I mean. None of this is rational? Too bad. If you multiply -2 by -2, 2 negatives equal a positive. So -2 also is the correct answer. So technically, the answer is positive or -2 for the square root of 4. But usually you don't bother with that too much. But the thing is, yeah, you cannot multiply a number by itself and get a negative number. If you're taking like the cubic root, you can, yeah, that's fine. But the square root, or the 4th root, or even any even number root, you cannot get a negative number as the answer. So, what they do is just do square root of 4 times square root of -1. Should bother with it? Oh no. So you can get an actual number. So that would equal 2 times the square root of -1. So you can't really do anything with the -1. Yeah, the notation for the square root of -1 is just I. Stands for imaginary, I assume. So that will be, well, that is relevant actually for quadratic equations, because we will get we'll get I as an answer, or just imaginary numbers as answers for this, because we do have a good chance of getting a negative number here. No, don't use square root of -1. It has special rules attached that can be easily overlooked. Oh. Is that not the proper definition of I? Huh. But anyways, hold on. Let's finish this for now. So, two of our answers. So, got -4 plus and minus 6.78 for our two answers. So, x equals, let's see, for -4 minus 6.8 would be -10.78, and x equals tricky bits when eyes interact. I see. Yeah, just for answer notations. Oh, it's defined as the solution to the quadratic equation x2 plus 1 equals 0. Do you mean x squared? If you wanted to use the up caret, I think is the proper way to define that. 0.78. There we go. So, let's see. Square root of a squared. So I squared does not equal that. Okay. Copy and paste. Coward. Base to cringe. Base 6. Cringe. You either go all the way to Math Chuny and do base 12, or go all the way to Math Weeaboo and go base 2. Square root of a squared equals absolute value of a. Interesting. Base to cringe hexadecimal. Kinda based. Base 36. Is that like the is that the new trend? I don't know. But anyways. Oh, but we still haven't finished our first equation. Wait, no, we've done several equations. We haven't finished the one we're bothering with at the moment. But let's see. So, I think we have to flip these. It's been a hot minute. So, base 36 just continues hexadecimal with the complete alphabet. Oh. Compressed base 36 reason you have 5 fingers? No. Hexadecimal is cool because it's just for funny computing stuff. Because it's 4 bits. The old you got 4 bits. There you go. And you condense that into one number basically. Don't worry about it. Any counting system that doesn't account for you having 5 fingers on each hand is a dumb system. No. Let's see. Switching from a base to a version of that base with a higher exponent is easy. Base 60 is for Zoomers? Why 60? You wear shoes? Sorry, no shoes allowed in math institutions anymore. That's just the rules. Sumerians. No. However. Just goofing off. Omega Babylonian boomers. What? Base 6 for high IQ individuals. I bet you go to home base and go home. Anyways. I guess since I've forgotten the exact details, we can just math it out. Let's see if I get this incorrect. I think I did. I believe we had... Yeah, let's do it wrong for fun. Totally not, because I want to see if I got it right. Ah, shit. Sumerian and Babylonians use base 60. So we have 360 degrees for a circle and 60 minutes for an hour. Ah. Minutes are also used in degrees. Right? Baseball is base because they have 4 bases. Oh, like base 2 to the 1 to base 2 to 4. Yeah. The binary to hexadecimal. So let's FOIL this shit out. So x squared minus 10.78 x. This ain't looking right. This ain't looking right, folks. No, this is looking correct. No, we're fine. We did get it wrong. Yeah, it's the inverse. I mean, the opposite. Base to cringe baseball. It's just like chess, but with baseball players. So yeah, these are the points when x hits 0 on the graph, if you were to map it out. So, when this equation hits 0, is when the x is either of these values. So, oops. Base is in the name. No, base is. You count to 31 on one hand? Exactly. Is baseball a solved game? No. Yeah, it is. The winning move is not to play. So. There we go. So. This equation right here will equal 0. It's a rigged game. Aren't they doing that with NFL now? Now that they've got proper betting on that, they implemented some rules to allow judges to pretty much completely, referees to completely swing games. Could offensive play succeeds less than 10% of the time? Cringe. So, if we have negative 10.78 as x, then, guess what? Negative 10.78 plus 10.78 equals 0. Yeah, we learned that in the cheat sheet. A number minus itself equals 0. Guess what? 0 times whatever the hell happens here equals 0. So, there you go. X is true for that number. And if we were to substitute 2 in for x, 2.78, yeah, for x, plus 10 equals whatever, I don't care. 2.78 minus 2.78 equals 0 as well. So 0 times any number will equal 0, and there we go. The answer raises. Eh? Hmm? But yeah, that's how you. That's how you do the quadratic equation. Let's go ahead and. Well, that was factoring, right? And then the other way around is simplifying. Whatever. The words don't matter. The numbers matter. So x squared plus. Yep. Well, I guess we could do proper FOIL. Outside is x times negative 2.78. Plus 10.78 x. And then minus. Let's plug this into a calculator to see how close it gets. Uh, 29.968. Damn. Now, not the addition or subtraction, the multiplication. That should be close to the... Yeah. Yeah, that's what happens if you don't take enough decimal places, but let's round that up. Damn. Yeah, that'd be 29.97. Oh, we're running out of room. No! Unfortunate. So, that should be 30. That's why you take another decimal place or two. However, it's close enough. So x squared plus, so yeah, negative 8 plus 10. Yeah. Wait, how'd you get negative 8? Yeah, what the fuck? See me after class. No. Yeah, and then that should be minus 30. Which, guess what? That's what we started working with. Yeah, exactly. Yeah. So we successfully, except for a few decimals, we successfully factored out this. The whole x squared plus 8x minus 30 into x plus 10.78 times x minus 2.78. Kind of bullshit. I guess the only other thing to touch on with this is polynomial long division. Fuck that. Let's go to the fun part. Sets. So, do a set. Now, I've done this one on stream before, but we will use this in just a moment once we go to video games. A to the n equal, well, whatever. Hold on. I'm gonna use the curly braces. Ah, shit. Yo, video game reference. I'm pogging at the cave story reference. Yeah, equals. Yeah, this is the how you're supposed to notate sets or whatever. Put the numbers in like this. So 1 plus. Oh yeah, we go. So this is what this is defining, We're adding 1, then we're adding 2, then we're adding 3, etc., etc. To the same number. It's the sum of consecutive integers or whatever. So 1, we add 2, we'll get 3. We add 3, we get 6. We add 4, we get 10. Add 5, we get 15. And we add 6, we get 21, etc. So there is a simple formula is the answer for this. So the easiest way to solve something like this is just divide it by x, and then if it looks like it's still going up exponentially, then divide by x again. Some stupid shit like that. But I guess we could solve this. So let's go ahead and divide the whole thing by x. Yeah, whatever. This. Let's be based and make this a function, or just call it a function. I don't know if that's proper. Whatever. So let's just divide it by x. So 1. No, it'd be by n. Because n is a whatever. So 1 divided by 1 equals 1. 3 divided by 2, 1.5. 6 divided by 3 equals 2. 10 divided by 4 is 2.5. And 15 divided by, what was it, 5? Yeah, 3, 3.5, etc. We're already getting close to a pattern. This should be pretty simple now. Starts at 1. Goes up by a half. Let's see. We can multiply it by 2. Then we get 2, 3, 4. You never know if your guess is correct because the sequence is incomplete. Well, good point. But yeah, we can define the sequence as just the sum of consecutive numbers or whatever. Yeah, then we do have the definition, though, of... I don't know how to write this properly in math language. There we go. We are adding the sums, etc. So 15 plus 6. The sixth number is 1 plus 2 plus 3 plus 4 plus 5 plus 6, which equals 21. The seventh number, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. F of A equals n plus n. No? No. A little close. But yeah, the next one would be 28, etc. And now, yeah, 28 divided by 7 is 4, etc. Now, if we multiply these by 2, some n from n1, x inclusive. That might be the proper way to define that. It's been a while. I know this gets you into Bernoulli numbers. Once you do sums of consecutive numbers to the power of whatever. Something like that. I don't know. But this will be useful in a moment. Etc. And now, we just subtract 1. And we get... Did I use x? Okay, good, I used n. 1, 2, 3, 4, 5, 6, 7, etc. And now, if we divide by n, a0 equals 1, an equals an minus 1 plus n. Ah, fuck. You're dabbing on me. If we do this, then we just get... We divide this by 1 by 1, 2 by 2, divide 3 by 3, we'll get 1 repeating. So, there we go. So let's do the reverse. It's evil? What? Is there in fact morality in math? So we have like just nothing. Multiply it by n. Add 1. Multiply it by 2. No. Divide it by 2. And then multiply it by n. There you go. Fibonacci is good, this is evil. What? Are you telling me an equation this simple is evil? We can simplify this easily by multiplying this by n. So we can get n squared. Prove that it's evil? I cannot. Plus n over 2. There we go. Good night, blessed heretic. Sleep tight. Don't let the bed bugs bite. Don't let the math get to your head. So, let's see. Well, I mean, I could just do this for any number. Let's say, well, we've got 7 right there. So, 7 squared plus 7, or you could just do 7 times 7 plus 1. Here's another way to look at it. I mean, you can just not factor it out, or whatever. Over 2. So, 7 times 8 equals, what, 56? N to the power of n plus 1? Eh? No! And then divide it by 2, and you get 28. Prove it for all possible positive integers n. Okay. Where did I put that tab? Math. Bring the browser back. There we go. Well, welcome to the graph. I don't know the proper way to prove something like that. It's been a while. So, you just do x to the power of 2 plus x over 2. There we go. Now, this is the function. So, there's the I don't know exactly how to use this, but it'd be nice if I could just check any point. But 0, 0, and negative 1 doesn't matter. So at 1, it equals 1. Correct. 2, it equals 3. 3, it equals 6. Etc., etc. Let's go all the way up to a number like 10. Should be 55. Correct. Should be a table view. Oh. definitely not there. Hmm. Ah, here we go. Oh. You can put it in terms of okay. Hmm. Interesting. Oh. This might be a little bit easier on the eyes. Hmm. Doesn't look like there's a table view on this one. Wait, Braille mode? Interesting. No, I was not aware of something like that. Ah. Hmm. Maybe there is a better one for that then. Let's see. What's the point of Braille and a screen? So I was a little bit surprised by that. Hmm. What, does Wolfram Alpha have a good one? Hmm. Isn't the whole point that it's tactile? The numbers aren't. Hmm. Let's see. Can I have it show in a table? Hmm. Doesn't. Damn. Oh, there's a math-specific Braille. Interesting. Anyways, we will be using this later. Hmm. Ah. Very nice. I think the reverse contrast might be a little too much. Hmm. 0, 100. See. I get a -1. Alright, we'll just 0 work better. Yeah. Use Braille on a screen to draw pictures with the dots. Prettier than ASCII art. Hmm. Does it have the same soul? If you're going up to 100, then 15. There we go. I should show a little bit of the -y just for fun. There we go. Good morning, Xavier. Welcome to math. Hmm. But yeah. This is the equation for the sum of consecutive integers. Do step 1. And 1. There we go. Isn't defined for negative numbers. No. I was saying just to make it look prettier. I wish I knew how to do that with the graph. Hmm. We do have some silly stuff coming up. So. Maybe I should bring it back to Krita for a moment. Hmm. Yes. Let's see. Where'd I put my pen? Okay, good. I put it back in the tablet. Okay. But yeah, welcome. Well, you're a bit late to class. However, let's start going on to video games. So... I have to hide this. There you go. Welcome back to Krita. Okay. So, I'm gonna do the... Folk Fables. The, The B has the boomerang. I guess, yeah, there's some Paper Mario moves as well that do this. However, how it works is it deals... Let's see. What should I use for the attack? I don't know. Fuck it. N. So, let's say N equals power. Hold on. No, I'm smarter than this. P equals power. So yeah, the tornado toss or whatever. So it does one less than that for the first hit. And it hits multiple times. So P minus 1, P minus 2, P minus 3, P minus 4. I think it does 4 hits normally, and you can get an upgrade where it does 5 hits. Let me double check that. Yep, up to 4 times normally. Yeah, it should be 5 times with the upgrade. Good morning, Aaron Chris. Welcome to math. Currently using the powers of math for Bug video game. And it won't ever go below 1, which is why I wanted to be able to do silly stuff with that graph. However, guess what? 1, 2, 3, 4. The total damage would be all of these added together. I mean, there's a much more complicated way to do this that I was going to do. However, yeah, I guess it is just subtract. Damn it. But yeah, so 5 for that previous equation. But yeah, oh, also you are late to class. So yeah, 5 plus 4 plus 3 plus 2 plus 1 is 15. Math? No! So we end up with 5p minus 15. And there we go. As long as, p is greater than the... Well, I guess x is fine for this. As long as p is greater than 5. Yeah. It doesn't work for 5. Because this would be 1 damage instead of 0 damage in the game. However, we're going to be comparing, I guess, high-level DPS. And then... Yeah, let's graph that first. So... Yeah, I guess we don't really need that. Damn. So that would be 5x minus 15. Yeah. Yeah, say, I wish I had fine-tuned for this. Doesn't seem correct. Wait, no, 10 damage at 5. No, it should be... Yeah, 15 damage at 6. Let me do the math in my brain for a moment. But yeah, no, that makes sense. Yeah. So... let's compare that to... Yeah, I really wish I could get that exactly how I wanted. However... Compare that to other character, Leaf. I don't remember exactly how his head works. He's got the, oh yeah, he's got the eyes like that, yeah. But he has a multi-hit move as well. However, I believe it just hits 4 times. It's a little nice move. Yeah. So, it just simply does P times 4. I guess, whatever his power is damage multiple times. So just 4p. So, we can go ahead and plot that as well. There we go. Oh, you can't add a table. Oh, interesting. What if I do something like this? Nah, it just plots out points. Interesting. Well, the more you know. We can add an image. What? Interesting. There we go. So now we can see when the DPS matches and when the DPS, I guess, gets eclipsed. So if you manage to get 15 power on either character, they'll do equal amounts of damage with their special moves. However, let's see. Yeah, all the damage boosts. Yeah, so you will actually end up, and over the course of one turn, you can end up doing more damage with V than Leaf. Yeah, I believe you can get around that much. Maybe it's like 16 power in one turn. Something silly like that. Yeah. Do like 65 damage with V as opposed to 63 with Leaf. Yeah, there you go. Now you can compare DPS. So as long as you have... Well, I guess you also have the TP cost to take into account. But for the most part, that was everything I had for video game stuff. Although I guess there's all the Paper Mario moves. I believe that jump. Yeah. Actually, I do want to know the exact details. I don't remember the name. Power Bounce. There we go. Does it stop you? Okay. Yeah, Power Bounce just does infinite damage. However, we could define it. Well, but now this doesn't let us stop at the 1. If only this is a little bit better. Or I was a little bit smarter and knew how to use this properly. Hmm. However, let's see. I do have a silly idea. It's the World of Warcraft well-rested bonus. I wanted to look this up properly beforehand. Ah. Hmm. Interesting. So, the well-rested XP bonus. Let's see. It gets you XP at a rate of 5% for 8 hours. Now, how does this compare to gaining experience normally instead? Hmm. So I would like to... This is how you use math in real life. Is you use it to analyze... Well, first of all, just don't play World of Warcraft. Especially now. Second of all, let's see. How much not playing World of Warcraft can we get away with? So... How exactly does that work? The 150% of your level? I guess it depends on your level's experience. Let's see. We can make some assumptions. So... Caps at 150%. Let's say you gain levels at, I don't know. I guess this would require a little bit more knowledge of how quickly you actually gain experience from killing mobs. I guess that's another variable that we can change. So, let's see. %5 for 8 hours. Now, it takes 10 days to get a full rested bar. So we want to see what point is it better to, if you're going to be playing, like, how long per week? Is it better to, I guess, just play during the rested bonus versus not? So if you're doing this kind of math to determine how long you should play a video game each day, that does make it more like a job. So let me repeat this again. Don't play World of Warcraft. It's just proto Discord. Anyways. So let's put in some silly numbers. Let's say it takes you, I don't know, 2 hours to level up. That doesn't seem right. No. Maybe that is. It's been a long time. I guess at higher levels that's not the case. I don't know. Let's assume we're only using combat to gain experience. So whatever. It's is it double experience? Ah, fuck, it doesn't actually tell you. Damn it. Those bastards on this on the wiki. Does it tell you on the other wiki? Really not. Oh, it is double experience. Okay. There we go. Yeah, I remember the actual thought process behind rested XP was the reverse. So they originally designed it so that you got less experience after however long of playing. Like, you got like an experience penalty after a certain amount of time, or a certain amount of experience, and without resting. And people didn't like that, so they just swapped the numbers around to be a bonus, and then people liked that. There you go. Now there's a World of Warcraft history lesson. So, let's see. Well, we need to split this. This is stupid. Well, let's finish this. The answer will be something silly. If it only takes 2 hours to level up, then it would take 1 hour. At once you hit 100% of the whole thing. Have rested bonus. Because that means you'll get the rested bonus for the entire the entire level bar. Let's see. Is there any good way to define this? We can use for a graph. So for every 8 hours that you spend playing, not playing, well, no. How long does it actually take to level in World of Warcraft? Fuck. Anyways. Or... So it caps at 150%. So that's like 1.5 levels of double experience. So if it takes... Yeah, so if it, I don't know, so if it takes 6 hours for 3 levels, then it'll take... It caps at 150% though. So yeah, you get 1.5 levels in 1.5 hours. But... Interesting. I'm stupid. Yeah, it takes a total of 10 days, so... Yeah, 240 hours? Is that correct? 8, 16, 24? Yeah. So for every 240 hours that you don't play the game, you save an hour and a half? Yeah, because it'd be 3 hours to level 1.5 times. Let's see the actual times. I wonder if anyone has actually compiled the information for that. Time per level. Oh, this is for classic. Interesting. Oh. Oh, the first 48 levels aren't the same as half the next. The first 48 levels is the same amount of experience as the last 12. Interesting. Let's see. It takes twice as much experience to get from 60 to 70 as it does to get from 1 to 60. Interesting. 2 to 3 days of game time to get from 60 to 70. If you don't take any breaks or leave your character AFK in a major city. Okay. So let's take the worst case scenario. Let's say it takes 78 hours. And no, I don't know why I'm doing this. 70 hours for the last 10 levels. Be nice to have the data for each one. So, yeah, the obvious answer is if we divide that by 2, the 39. So that'd be 39 hours if we had the well-rested buff. And then, let's see. How long would we have to rest for that? I don't know if I could graph this. I should have thought about this one beforehand. Let's see. So yeah, 150% levels per 10 10 days. Let's see. Yeah, 240 hours for every level and a half. So 6 plus, oh yes, 6 and the 2/3. Yeah, so, or times 240. Yeah. Well, no. Let me write this out properly, so you can actually see what I'm thinking about. So 10 levels divided by 1.5, because we get 1.5 level per full bar of well rested, and we get a full bar of well rested every 240 hours. I guess we could have done the whole 8 hours per percent of a level. So, I guess we could do that as well. Doesn't really matter, but this might be a better way of looking at it. So, that means 5% per 8 hours, we get a whole level at 20 times 8 and 160 hours. Yeah, whatever. So, 160 times 10 is 1,600 hours. AFK. To play as little, yeah, to go from level 60 to 70 in World of Warcraft with playing as little World of Warcraft as possible. At a casual rate. You can spend, how many days is that? Let's see. Cool. 66 days. And 16 hours. AFK to get the well-rested boost. For the whole thing. It's not including quests or anything like that. But interesting. Let's see. Oh yeah, and 39 hours of actual gameplay. In the meantime. Interesting. Well. The Bug Fables math was more fun. Anyways. I was gonna say I ran out of content. However, there is one thing I can do. Let's actually use what we learned. And where's the daily the daily problem? Okay. Here we go. Go ahead and switch to the browser. And let's work through an Algebra 1 problem. This should be extremely easy for us. Alright. Oh, and I can use the graph for this one. So, interesting. It's a word problem. We'll have to open up the tab. Bring back Rita. Damn it. So, we're going to find which animal moves the quickest. Oh wait, this is simple. We don't really need this. Yeah, we don't need to really work through this. We can actually guess with this one pretty easily. Sloth moves 6 centimeters in 1 second. Tortoise goes 4.2 meters in 1 minute. So that's 420 centimeters in 1 minute. Times 6, or 60 is 420 centimeters in... Well, 420 times 6 centimeters in a second. Wait. Fuck, I'm stupid. You gotta divide it. 42 divided by 6 is 7. So 7 centimeters in 1 second. Yeah, let's work this out on paper. So you can call me out for getting that wrong. There we go. Oh no. No, Krita. There we go. So, let's see. Save check. Yeah, I did have to save it. That is the way that the Krita window comes back. So, sloth is, yeah, 6 cm per second. Let's bring it up to meters. 0.06 meters per second, because that looks cooler. 4.2 meters in 1 minute. No. But yeah, thank you for reminding me to save. Let's see. So, good morning, chicken wing. Math on Twitch. Yeah, welcome. This is near the end. But let's see. I'm currently doing a, I found a good, I found an okay problem online. Simply this. But anyways. I mean, I could bump it up all the way to calculus, just to see. However, currently trying to figure out which is the fastest. Using all the algebra that was just taught. Yeah, this is a lot of ratios. What was it? 4.2. Out. There we go. I don't like it when that happens. Meters per minute, which is 60, whatever. So, yeah. How would you do that? How would you show that properly? Well, I guess you could just per 60 seconds. And then you'd have to divide both sides by 50? There's 60. Whatever. Yeah, well, no, this is a good teaching moment. I'm supposed to be teaching people. So, there's 60 seconds per minute. So, whatever, I'm not qualified for this. The fucking union can fire me. So meters per second, and we divide it by 60. Am I a math teacher? I am not. That's part of the fun. So, we can simply divide 4.2 by 60 to get the meters per second. So divided by 42 divided by 6 is 7. So, and then divided by 10, we put an extra 0. Well, we may as well do it the fun way. So 0.7 over 10. If we just divide the 6. And then, yeah. 0.07 meters per second. Now, it's on the news that a teacher uses Twitch to teach their students. Oh no. I'm not a teacher or the news. A spider goes, let's see, 1.6 kilometers per hour. Okay, we will have to mess with units. Alright, welcome to actual math. Now, let's see. 1.6 kilometers per hour. So, we need to get convert the hour to seconds. And the kilometers to meters. Holy fuck, that's pretty... Wait, let's see how fast that is, actually. No, kilometers per hour isn't that fast. So... 1 kilometer equals 1,000 meters? I think. I am, in fact, American. 1,000 over 36,000. Yeah. Okay, it is 1,000. And 1 hour. Yeah, that is correct. Equals 36,000 seconds. Because, yeah, well, equals 60 minutes, and then 1 minute equals 60 seconds. Multiply them together. No, there's no problem. So we end up with 1.6 times 1,000, and then divided by 36,000. So we can already remove some of the zeros. So first of all, we can take off 2 zeros from the oh, wait, did I say 36,000? Whatever, 3,600. 3.6k. Thanks. I grew it myself. Nurtured that skill. So, yeah. We can just cancel the zeros out, like so. So, we simply get 16 over 36. Go ahead and simplify that further. Or reduce it, whatever. So we can divide both by 2 easily. 8 over 18. Okay, do it again. And good morning, chaotic evil ogre mage bottom. Welcome to math. So 4 over 9. Yeah, that should be correct. This should be correct. Let's see. What is 4 divided by 9? Let's get it in decimals. Alright. I may as well do that over here. So, 0.4 repeating. Alright. How is it 0.4 or is it just 4? Oh, okay. Yeah, that makes sense. I guess we may as well just round it. Like so. And then, but yeah, here's the equation that we're, I guess the problem. It's not an equation. We're turning it into equations. There we go. And then a snail going at 1.2 centimeters per second. Yeah. I guess this does show, I don't know, substitution of variables. I should have thought about what it was, what I could teach from it instead of just doing it. I guess that's the difference between a good teacher and a random dude on the internet. So, 1.2 centimeters per second. We want to get that to meters per second. Oops. That should be relatively easy. Oh. There we go. Crete is back. So again, good morning, Pujigire. No, why are you disappearing? Oh yeah, you're also all late for class. What was the number again? 1.2. 1.2 centimeters per second. We already have the proper unit on the bottom. And 1 centimeter equals, let's see, 0.01 meter? Yeah. So, we can replace that 1 centimeter with 0.01 meters. So, 1.2 times 3.01. But I put another decimal there. Meters per second. AKA 0.012. Fuck. The snail is the slowest. Frickin' sweet. Okay, if I get this wrong, I'll be very embarrassed. So, the spider is allegedly the fastest. Oh. There we go. Alright. Okay, good. Ah, let's check our work. Oh, they did make it in meters per second as well. Nice. So, we got all of them correct. The spider is the fastest. I can't believe this is true. Is that Liz Bill Gates? Interesting. I didn't realize you could submit your own questions. That could be fun. However, let's see yesterday's question. Oh yeah, this one's interesting. For which value or values of x can, whatever, not be simplified? Alright, yeah, this is actual. This is much more algebra than the previous question. Alright. Yeah, let's go. Alright. Let's see if we can do this with no issue. Alright, it's back. So, x squared minus 5x. And oops, plus 6 divided by x squared plus x minus 6. There we go. So we're gonna do the fun part of math, which is factoring. So let's do each part of the fraction individually. So, I mean, okay, no, it's easy. So, we can make 6 by multiplying 2 and 3 together, and 2 plus 3 equals 5. However, this is negative, so we could just do negative 3 times negative 6. Yeah. I mean, negative 2. We could bring this... Yeah, we could use the quadratic formula on this. No, let's do that real quick. So, negative b, write it up here, plus or minus square root of b squared minus 4ab over 2a. So, to do this the quote-unquote guaranteed way, negative b would be 10. Or is it negative 2b? Let me triple check. Okay, good. I'm not crazy. So 10 plus or minus the square root. Yeah, this should be an even, or not an even number, but an easy number. It was negative 5, yeah? That's fine. We'll just do... It's exactly the same as 5 squared, whatever. And we'll write it out. Minus 4 times 1 times... Normally use trial and error. It does work. It's a little bit silly. And it does work in this case because the numbers are so small. It's easy. Yeah, and that's also a 2 and a 3. Don't tell anyone that. Times negative 5. There we go. Over 2. times 1. So we just get 25 minus negative 20, so plus 20. Is this correct? Huh. Yeah. Plus 6? It is. Hold on. What did I fuck up? Oh, AC. Yeah. Yep. I knew it was messed up. Yeah, see, I'm teaching you how not to do it. Don't pay attention. But do as I say, not as I do. So that would be 6. What? Nah, 4 times 6 is 24, so that'd be the square root of 1. This doesn't seem right. Is this right? That would be... we get 9 and 11 divided by 2. Really? How the fuck did I get my teaching license? Yeah. Yeah, interesting. Yeah. I don't want to go too far with the wrong answer. Well, this is a good idea. I'll show you where you can go wrong. None of the other... Wait, no, not plus. Yeah, minus. Does this work with... Really, did I mess up somewhere? Because 49 is 7. We end up with 10... Get 3. Huh. What the fuck? Eh? Yeah, I know it equals 1. Then we take... so then it'd be 10 plus or minus the square root of 1 over 2. So we'd either get the square root of 1 equals 1. So, and 10 over 2. Interesting. So 10 minus 1. Why is it 10? Oh, it is just negative b. Holy fuck. That is negative 2b. Okay, hold on. I did say... There you go. See, that's how you can mess up an equation. Don't tell anyone. So it does work. Okay. Yeah, that's what I was stuck on. Yeah, 2b. It's because the Nier soundtrack was playing. It was messing me up. Turn off Nier. No. Fuck. There you go. 5 minus 1 over 2. And 5 plus 1 over 2 are our two answers. So 4 over 2 and 6 over 2, aka get 2 and 3. Oh, they're both negative, yeah. It's not appropriate. But the new soundtrack? No, I did no. Yeah, I don't know how I feel about that kind of content in video games. So that means that x squared minus 5x plus 6 will equal 0 when x is 2 or 3. So that means x will equal our numbers will be -2 and -3. Now for the bottom, well, no, let's do this the hard way again, just because. So -b, not 2, plus or minus the square root of 1 squared minus 4 times 1 times -6. There we go. If I was a teacher, high school or primary school students, that's oh no. What this equation is trying to find the circumference of. Eh? This is nowhere near the equation for circumference. What are you doing? So, did I get all those numbers correct? Yeah, there's a -6 over 2 times 1. So, I mean, -1 plus or minus square root of 1 minus plus 24. So yeah, minus -24. You get that -6 times 4, -24. Subtracted a negative becomes addition, and then over 2. So yeah, that square root. Yeah. -1. Now that I haven't messed up anything. So minus square root of 25 over 2. Okay, -1 plus or minus 5 over 2. Alright. So, our two answers. -1 plus 5 over 2. And -1 minus 5 over 2. So, -1 plus 5 equals 4 over 2. 2. And -1 minus 5 equals -6 over 2. -3. We take the opposites. Because this is x equals 0. Or the equation equals 0 when x is either of these two values. So, I guess we could check that also in a moment. X minus 2 times x plus 3. So yeah. Yeah, so for 2 on the bottom one. So yeah, if we had 2 squared, we'd get 4. Plus 2 equals 6. Minus 6 equals 0. Okay. And then same for -3. -3 squared equals +9. Plus -3. So 9 minus 3 is 6. And they subtract 6. And then we get 0 as well. Yep, that worked out correctly. Now we get the same answer down here as well. Obviously, if we do 2 minus 2, we get 0, and 0 times anything equals 0. Yeah. But anyways. Now, we can simplify this equation. They cancel each other out like Twitter. No! I believe what we do in a situation like this is we do this, and then x doesn't equal 2, and then x minus 3 over x plus 3. Yeah, because if it equaled 2, then we get a divide by 0 error. Let's check our results. I may have skipped over that part of the lesson. Next I have to calculate the punchline. No. Yeah. So, cannot be simplified when x equals 2. Yeah, should be correct. Right? Yeah. Numerator can be factored like this. Yep. X minus 3 and x minus 2. X minus 2 and x minus 3 for the denominator. Yeah, we cannot cancel the factor x minus 2 if it equals 0. Oops. There we go. Nice. I solved mathematics. 42% answered this correctly. We are in the 42% of math gamers. Okay, what's calculus look like today? No, what's algebra 2 look like? Express in partial fractions. Okay. Let's not. Let's solve some grade 2 math. How long is the chisel according to this ruler? Okay, let's solve some grade 3 math. Oh shit, here we go. If a woman started with 60 balloons, then added 50 balloons every day for 3 days, how many balloons did she end up with? 60 plus 50 times 3. C is always the right answer. Yeah. Alright, let's try calculus. What is the slope of the function 1 over x at x equals 2? C is always the answer. Fuck. Well, that's enough to get fired from my job. So, who's online right now? 140 balloons, they popped a lot. Those are the balloons that they sent towards the monkeys in Bloons Tower Defense. There's your deep lore. Oh shit. Shady. Shady's online. What about the quiz? I didn't make one. I was too busy preparing the previous stuff. Where's the wish granting quiz? Now that I did do a more proper lesson earlier, I guess I could do several wish granting quizzes next stream. I don't know if I'm missing anything with Algebra 1. You want to get an A? Okay. I'll tell you how to get an A. Just study. Get really, derivatives are in the calculus one? Really? It's yesterday's question. 0.1 x squared minus 5. Use the graph to estimate the slope at the point in the curve. The x coordinate n. About 2. Really? This is this is how difficult calculus is for these questions. Interesting. Well, why don't you best at not studying until 30 minutes before a quiz. I'm the best at not preparing until 30 minutes before the stream starts. Nah, just kidding. I spent like the past few hours. I don't know. Looks hard. It just says to estimate the slope. The slope is the angle. It's not asking me to calculate the derivative. What was today's question? What's the slope of the function y over x at x equals 2? Oh, you don't remember? I see. Well, Hmm. Keep Vergar. Uh, let's go bully Shady. Uh, hmm. Actually, yeah. Why doesn't everyone just ask him a bunch of equations? Vergar every theorem. Yeah. Well. I don't have anything specific planned for next Friday yet, but Friday after next will be another math stream. I'll make sure to have wish granting quizzes, multiple in fact. I guess I should say. Here you go. If you want to study, check this out. Fun frog math facts. One shady remains. Yeah, there's there's a good website for actually learning math. Anyways. Let's ask Shady a bunch of math questions. Tomorrow, Dungeon Crawl Stone Soup. Day after tomorrow. You and the frog fraction. Because have a good day, everyone. Let's see. Oh yeah, Enter the Gungeon this Sunday. I did like doing a bit of math with video game stuff. The ones that I got correct. Well, anyways, have a good one, everyone. Sleep tight, don't let the bed bugs bite, and bother Shady. Call him a nerd.